Okay, so today we are going to discuss about PWM. PWM stands for pulse width modulation. Okay, so pulse width modulation is nothing but, see, there is like a wave. So here, this wave you are going to modify. It means like you are according to the need, you are going to change it to maybe got it right? Maybe this way, or so what is the difference here? This is you take, here is a 1 clock, right? This is 1 clock. So the 1 clock is we can the 1 clock can be also called as like a 1 period. Okay. So this 1 clock is having two portions. One is a on, that is I, and other one is a low. So the I we can call it as a T on, the low we can call it as a T off. Got it right? So this combinedly we are calling it as a 1 clock or 1 clock period. Okay, that is fine. So the T on period time is defined by the term called duty cycle. Getting right? So here the T on alone, there is another name for the T on, the other name is duty cycle. It's an important interview question. What is duty cycle? If somebody asks, you have to say in a clock the T on period is called as a duty cycle. That's all. So the T on time is called as a duty cycle. Now this is, you see, here you have 1 clock, another clock, another clock. What is the difference you see in this first wave, second wave, and the third wave? So first wave, so T on and T off is equal. Very simple, no need to get too much of confusion. So T on, T off, both are equal. Coming to second one, T on is very less than T off. T on is less, T off is more. Here T on is more and T off is less. Okay, whatever the ratio under we will see. That I will come to that. Okay. So according to the need, what you are trying to do is you are controlling the waveform. Got it right? See, this is regular one. From this regular one, you are trying to modify like this or some other way. So you are trying to control the T on 50. T on 50, T off 50 is the regular one. Got it right? T on 50, T off 50 is the regular one. What you are doing is you are modulating it, modulating the wave. Got it right? That's the reason it is called as a pulse width modulation. The pulse is like a modified. How it is modified? T on may be like it is instead of 50%, T on may be like a 10%, T off is 90%. T on is like a 70%, T off is 30%. T on is 30, T off is 70. According to the need, you are going to modify. Getting right? So now the thing is, sir, why I need to modify? What is the purpose of it? Okay, once is like a how we are modifying, that I will come. First of all, like why I need to modify? What is the purpose of it? It is very simple. By making this like a modulation, what you are doing is you are going to generate the voltage as an analog voltage. So today's session is completely opposite to yesterday's session. So yesterday what we discussed, I'll come back to this. Yesterday what we discussed, you are giving some analog voltage. Okay, whatever it may be, you have temperature sensor or you have pressure sensor or you have any type of sensor. Okay, whatever it may be the sensor. So from this sensor, some analog voltage is given. Got it right? So this analog voltage is taken, and here there is a one ADC. The ADC will take this analog voltage and he will convert it as a 10-bit value. Got it right? This is yesterday we discussed. And today what we are going to discuss is, today you are setting 10-bit value, okay? So you are giving 10-bit value, the 10-bit value is converted as a analog voltage, output voltage. Getting right? Yesterday voltage is given, the voltage is converted as a 10-bit value. Today we are giving 10-bit value, the 10-bit value is converted as a output voltage, analog voltage. Now you are giving the maximum number, then the output voltage will be maximum voltage. You are giving minimum number, then the output voltage will be minimum voltage. If you are giving anything in between, the output voltage will come according to that. Everybody getting right? So according to the voltage, if it is 2.5, then it will be the half number. If it is like a 5 volt, then it will be like a all 10 bit will be 111. If it is 0 volt, then all 10 bit will be 0. Got it right? Exactly same, exactly opposite today. So today is, we are going to set 10-bit number. That 10-bit number will be converted as a analog output voltage. Clear? That is one thing we are going to do. Okay. Now, so what is this 10-bit value? This 10-bit value is nothing but your duty cycle. Okay. So programmatically, what you are going to do is, you are going to set the duty cycle. Getting right? If you set the duty cycle as like a 50, it means like your duty cycle is what? T on time. So it means you are setting the value, the 10 bit. So in 10 bit, what is the maximum number? 1023. What is the 50% of that? 511. Okay. So if you set the 10 bit value as a 511, the output voltage will be off. Off means 2.5 volt. Clear everybody? Okay. So when you are, again I am repeating, if you set this 10-bit value, programmatically you are going to set the 10-bit value. Programmatically, if you set this 10-bit value as a like a off means it is a 511. 511 if you are putting in this 10-bit, okay, how we are setting that and all we'll see. Okay, you are setting 511. If you are setting 511, then the output voltage produced from this particular pin is, it is going to be 2.5. If you are setting all 10 bit as a 11, it means like a 1023 you are setting, then output voltage will be 5. Got it right? So now what is the 10 bit value is? 10 bit value is nothing but your T on. So you are going to control the T on. If you control T on is a 50, automatically T off will be 50. If you set T on is 100, that is 1023, then T off will be 0. If you set T on as a like a 10, T off will be 90%. Clear, right? That automatically internally managed. Only you are going to set the value for T on. If you are setting T on as a like a some percentage, remaining percentage is for T off. T on is 90 means T off will be 10. T on is like 70 means T off will be 30. T on is 30 means T off will be 70. Clear? So now according to the like a need, you set the number. That is one thing. Okay. Now, sir, what by making the pulse, what I am going to achieve? Very simple. You see, so there is a like a pipeline. Okay, assume that there is a pipeline. So in this pipeline, like if it is like a let's take like a for example 1 second of time full like the full water is coming, and 1 second of time it is completely off. 1 second on, 1 second off. Assume that way. Okay, there is a pipeline. In this pipeline, 1 second you are getting the complete water, and next second completely off. Next 1 second completely the maximum the water you are getting, and another 1 second you are getting off. So in that case, as an average, if you consider, you are getting the 50% of the flow. Got it right? So final output here is, it is a 50%. Is everybody getting it? So same thing happens in this case also. So what happens is, there is a one pin. Okay, what is which pin, that and all will come later. So there is a one pin. In this pin, what we are trying to do is by making duty cycle as a 50%. Let's assume duty cycle as a 50%. It means first, okay. If suppose your controller is working in 1 hertz speed, 1 hertz means how many clock it will generate in 1 second? 1 clock, correct, right? 1 hertz means that is the meaning. So it will generate only 1 clock in a 1 second time. So if your controller is working in the speed of 1 hertz, then 1 clock will be generated in a 1 second time. So what it will do is 50% of the time it will give output voltage as a like a on, 50% of the time output voltage will be off. It means 0.5 second, here you will get output voltage as a 5 volt, 0.5 second output voltage will be 0 volt. Everybody getting? Okay. So again I am recollecting, I am assuming my controller is working in the speed of 1 hertz and I am setting the duty cycle as a 50%. 50% means 511 I am setting. Getting right? So in this 10-bit number I am putting 511. 511, what is the equivalent binary is that? That binary I am putting in this. Clear? So now what is expected? T on time will be 50%, T off time is 50%. If my controller is working in the 1 hertz speed, then in that particular pin 5 volt will be generated for 0.5 second, 0 volt will be generated for 0.5 seconds. 5 volt, 0 volt, 5 volt, 0 volt, 5 volt, 0 volt. As an average, what is the voltage you will get? 2.5 volt you will get. Just now the pipe and water example I told, right? So same example, as an average voltage here it is generated is 2.5 volt. Okay. So sir, how if you are still confused, no? The light. So the light is actually it is on and off is happening. Correct, right? Yeah, everybody knows this, no? The light is actually in 1 second time, I think it is some 50 times or something like it is on and off is happening. I am not very sure, but there is a on and off is happening. The count I am not sure. So as a for human, but for us how it looks, it is always on. And again, if it is not on and off is happening, no, the brightness will be, if it is continuously on, no, the brightness will be more. It will be more bright. Since it is on and off is happening, no, we are seeing the average brightness. Getting right? Not the complete brightness. So sometime when the power is low, no, you must be seeing it is on and off, it will happen. You will able to recognize that. Because that time it is like the frequency is less. Not that 50% of the time, maybe it is like a 10 or 20% of the time it is happening. So 20 time on and off is happening so that we are able to see. Since if it is 50 time it is happening, no, our mind like we are not that super fast, so we are unable to recognize. Getting right? But as an average brightness we are seeing. Same thing happens here also. So when you are controlling this channel as a 50%, that is you are controlling only T on. So T on you are controlling for 50. It means the automatically T off is controlled for remaining 50. So on time is 50, off time is 50. On means 5 volt, off means 0 volt. So 5 volt, 0 volt, 5 volt, 0 volt. As an average, you will get 2.5 volt. Got it, right? Suppose you are expecting, no sir, I don't want 2.5 volt, I want 3.5 volt. Then what you have to do? What should be the duty cycle? I want 3.5 voltage. So your duty cycle should be 70%, and automatically T off will be 30%. T on is 70 means T off will be 30%. So that now as an average output voltage will be 3.5 volt. Suppose no sir, always I want like output voltage as a 5 volt. Then 100% you give the duty cycle, so it will be always 5 volt. So that you will get always 5 volt. No T off. Continuously you will be keep getting the 5 volt only. Everybody getting right? So that's the logic. Okay. So what you are going to do is there is like a waveform is generated. By controlling that waveform, you are going to control the output voltage. How you are going to control? Programmatically, we can control the T on time. So by making the T on time as like some percentage, remaining percentage will be automatically controlled, so that much percentage voltage only will be generated. If I make T on as like a 10 percentage, for 10 percentage, what is the number you take? That number you put it into that 10-bit register, so that you will get only 10 percentage of output voltage, that is 0.5 volt only you will be getting. Clear? Everybody getting right? So generally all our port A, port B, port C, port D, port E, these 5 ports are digital ports. Correct, right? Whether you are using it for input purpose or you are using it for output purpose, input you are giving means you will give either 0 volt or 5 volt. Output it is producing also, it will produce either 0 volt or 5 volt. That is completely digital input output port. All those 5 ports. Yesterday we have seen analog port. So in analog port only, in any of the analog channel you can give the analog input. Analog input will be 0 to 5 volt, in between any voltage, or it can be maximum voltage or it can be minimum voltage. That is analog input. And today experiment is, from microcontroller we want some voltage which is analog voltage, not just like a 5 or not just like a 0. Is everybody getting right so far? Now, sir, what is the use of this analog voltage? By controlling the voltage, by controlling like this much voltage only I want, what we are going to achieve? Yeah, very good. So if some motor is running like just you are making on and off, no, either it will be off or it will run in the maximum speed. Let's take robot. Okay, the robots are running slowly, it is walking. Sometimes it will walk fast, sometimes it will run. Robot means what? Again, there are any human, like for us we have like the skeleton and we have like the knee, all of that. Is the robot is having? Yeah, robot is having. In knee, what is there? Some motor is there. Correct, right? So that motor is running fast means the robot is running fast. It is taking step fast. Motor is running slowly means it is taking steps slowly. Motor is completely off means it is just like a standing. Got it, right? So obviously you will have a small motor or it is a big motor according to the device. Got it, right? So you can control the motor according to the need. So the robot is like coming with a lot of motor, lot of like every joint of the the robot is like coming with a motor. Small motors will be there. Like if it is a hand is there, here some motor will be there. Here if there is a hand, here some motor will be there. Ear motor, knee, everywhere like the motors will be there. So in one robot, if you take like several, maybe 100 plus like motors will be there, and those motors need to be coordinated. Correct, right? When one motor is like so when it is taking leg, you know, there are at least like 5-6 motor need to be coordinated. When this motor is running on this speed, other motor should be in that speed. Then only like it can take step and it can move forward. Got it, right? So these all how it is controlled using this kind of programming. Clear, right? Okay. So robot controlling the motor and controlling the LED brightness. Sometimes you don't want the maximum brightness or you don't want to be off. You want in between, like you want to increase the brightness, you want to decrease the brightness. Got it, right? So those kind of scenarios also you can use this. Suppose you want to like gradually increase the brightness. So slowly you like give 10%, 20%, 30%, 40, 50, 100. Got it, right? So then slowly brightness will increase. Again from 100 you gradually reduce the T on. Gradually the brightness will be decreased. So voltage regulation of SMPS. SMPS already we discussed, right, in our class itself. So in the CPU box there is we are giving 230 volt. The 230 volt is finally like coming as like a multiple small voltage, like a 3 volt, 3.3 volt, 5 volt, like that. So there also this PWM is used to convert it to say different voltage. And the speed control of motor, brightness adjustment of the LED. Clear, everybody? Okay. So today experiment is what we are going to do is just the PWM channel. There are two PWM channel in PIC 16F877A. We have two PWM channels. CCP1 and CCP2. We are going to use CCP1. CCP1 is channel 17, CCP2 is channel 16. So in these two channels you can generate this kind of analog output voltage according to the need. Okay. So today we are going to use a CCP1. CCP stands for compare, capture and the PWM. It means compare is like a one functionality, capture is one functionality, PWM is one functionality. So actually we are going to discuss only PWM. Compare and capture you leave it. So this channel, these two channels are used for compare. It means, I think, I'm not very sure, they may compare two different voltage and which is better, like that. And capture means, I think they can take some voltage and they can use it for some purpose. So just leave it. I'm just like not clear with it. But actually we are using only the PWM functionality of that particular pin. Okay. So for any question? So just to summarize, so PWM is as name says, we are going to control the power delivered to a circuit. So from this, like we are going to, whatever the power is delivered, whatever the voltage is delivered, that we are going to control, and control the voltages we are going to give it to some circuit, or that is LED or motor or whatever it may be. Okay, PWM waves are generated in a particular frequency. Okay, it will be in some particular frequency. That frequency, by controlling the T-on, it will be like a modulated. And applications already we discussed. And here like so one clock, as we discussed, like the one clock period is like a T-on and a T-off is there. T-on period is called as a duty cycle. And by controlling the T-on period, so your T-on and T-off will be T-off will be automatically adjusted. If T-on is 50, then T-off also will be 50. And T-on is like you are changing to 10, then T-off will be 90. So like that. So if your controller is working on some particular frequency, according to the like whatever the percentage of your T-on, the output voltage will be generated. And there are two PWM channels we have, that is CCP1 and the CCP2. CCP stands for compare, capture, PWM. So compare and capture we are not discussing, just we are discussing about the PWM. Okay, fine, let's stop.